So I've always been an advocate. This has been a very hot debate that, a lot of people see it as human versus agent or human versus computer. And I've always been interested in the question of human plus computer equals awesome, or equals more than anyone. So what I'll talk about today is a little bit about my experiments, kind of freelance experiments away from university. But I think, so this won't be like a purely theoretical event. We might need to do something about the door because I can see people who want to come in. And I just want to, talk a little bit about my perspective on the history of AI and how we got to where we are now. I'm going to talk a little bit about the problem with vibe coding. I'll talk about my favorite agentic coding system called Claude Code, including mine. And then I'll talk about a methodology I developed that really allows you to treat natural language like coding. And then I'll talk about some of the cool extra stuff we've done, and then I'll give you some thoughts. So this is a personal view of the 5 ages of AI. And some of us have lived through most of this. This is a personal take. I think Claude and I diverged around 2000s about what exactly is happening. But my opinion of my reading of the history of AI is the 1950s to 1970s were the end of the universe, where we thought AI would be each other. And then after the 1970s, we hit this kind of the AI winter that lasted for almost 2 decades. And the funny story I have there is when I started my PhD in 1996, I got a lot of questions about why I was doing AI, because it was a purely theoretical prospect. There were clearly no commercial applications for it. Why was I wasting my time? And yet here I am 25 years later, and I think those tricks have been proved wrong. Around the 2000s, though, something started to change. And I had this kind of rebirth moment where things got better. And definitely what we saw is a huge adoption of AI, and then the door is closed again if someone up the other or something. Huge adoption, like when I was at college time, about people using AI for everything from Netflix using it to predict videos and so on. And then in 2010, this is the area I was going to get is where deep learning took over and demolished everything before it. And I think we can be direct about that at the time. And it started in 2012 with ImageNet. And what happened there was a crazy situation where AlexNet, this deep learning-based approach, painted everyone else in the ImageNet competition by 10%. It was unprecedented. And then over the next 3 years, it went down from 26%, 27%, to 3.5%. And in that era, we started to get seriously strong performance from superhuman performance in various areas. And then in 2017, there was a very, very important key paper called Attention is All You Need that came out of Google by Russell Wanya now. And that's the one that introduced the transformer architecture that we now use today and still use today. That's the basis of all of the AI that we do. And then 2020 was one funny story there. So I was managing a team of people who were doing face recognition. I was in the Android team at the time. And my boss wanted to stress me out, so he gave me a team in Pittsburgh where I think, Claude, you did your PhD. Sorry. I mean, you do what?
Postdoc.
Yes, postdoc. And so he gave me a team at Pittsburgh that were doing face recognition. And their technology was all based on classical machine learning, AdaBoost, decision trees, everything else. And I managed the team, and I had to manage them through the era when the AI-based approaches came and completely wiped the floor with their technology. And basically, they became more interested in applications of face recognition to things like video, because the deep learning-based approaches completely trounced the classical approaches. And then in the 2020s, that's when we started to really see generalized pre-trained transformers come out. And the important paper that language models of future transformers, future learners, where they really showed that these language models had amazing transfer learning capabilities that we hadn't seen before. And then in 22, we started to see the power of stable diffusion for image generation. And then finally, in November 2022, that's when ChatGPT came out, and they climbed to 100 million users in 2 months, which no one has managed to match before. And I know that I'm speaking to a well-known audience, like an audience that knows this. By the way, asking clarifying questions at any point, completely okay. If they're controversial questions, we can help. And it's really 3 things that happened at the same time. The first one is massive amounts of training data. So it's estimated that GPT-4 was trained on 5 trillion words. It's hard to understand how much 5 trillion words is, but the way I count it is in terms of Wikipedias. So if you take all of the words there on Wikipedia, that's about 4 million words, I think. So 5 trillion words is like, what was the number I worked about it? 250 Wikipedias. I don't know if you know, but Anthropic, one of the companies, got sued in the US because they ran out of digital information. So they started getting books, cutting off the spines, and starting scanning OCR books to train their models. That's how desperate we're getting for software. The second was the transformer architecture. And the transformer architecture is really a very, very interesting architecture in the sense that nobody knows why it works, but we know that it works. And what it solves is essentially this idea of attention in words. How do I decide in a sentence, if I have a reference like it, what it talks to? And then the third one is unprecedented computing power. So this is one of the few times where consumer electronics has led to a social revolution. Basically, NVIDIA designed GPUs, and then someone discovered one day that GPUs were actually really, really good for doing AI as well. And now you have something like this box that costs $130,000. That's true, that's a lot. But it can do 150 trillion calculations per second. It has a ridiculous amount of RAM. Like I think it has a quarter terabyte of RAM or so, something like that. So those are the three factors that led, I think, to the AI revolution that we're living for. So this is where it gets a little bit crazy, right? So am I losing you guys? Everyone's with me so far? Too fast, too slow? All right? Okay. All right. So the thing is, really, when you think about it, these transformer models, their critics call them stochastic parrots, right? Because they're not really intelligent. What they are taking is the sum totality of human knowledge and resynthesizing it kind of like a parrot. In fact, there's a very famous paper from Google called Stochastic Parrots that Tim Greber and Margaret Mitchell wrote at Google that actually got them kicked out of Google. And so if you look up the paper, it says Margaret Mitchell instead of Margaret Mitchell. But the way that, so here are the three crazy things, right? The first one is the way that you should think about it is next word prediction is kind of like a Turing machine. You know how a Turing machine kind of has a piece of tape that goes forwards and backwards and types. Think of that and auto-regression as kind of like a Turing machine, except it operates in tokens and uses AI, uses like neural models. So it's amazing to me that just predicting the next token gets you this far, but it does. And we noticed that somewhere around the 8 billion parameter model plane, something weird happens where these AIs start to look conscious or intelligent or whatever. And I say look intelligent. The complexity here is we don't understand why this happens. We understand the maths, it's all just a bunch of matrix math and training, but we don't understand this emergent property. And then the scale from sophistication problem is the very real one, right? So I call this quote Jelinek's revenge. Frank Jelinek was one of the early researchers in speech recognition. And he has this quote where he says that every time I fire a linguist, the performance of the speech recognizer goes up. And now that was in 1988. And now he's absolutely right. The empiricists of AI have won. It's not pleasant. It's not good. I'm sorry to tell you this quote. The symbolic approaches of that.
We will have our revenge.
It'll be worse than that. You will be mixed in. Right. So I just want to zoom in on one particular topic within AI, and that is the idea of AI coding. How can we use AI to write tools? This is the reason that there's a company called Anthropic now that is responsible for something called Claude that is doing $4 billion in annual revenue from like nothing 18 months ago. So what happened is the first version of AI-based coding was what you might call single-line AI. It's like you open a chat window and you said, write a program that solves 9 queens. And I remember having discussions with Claude where I said, look at this, the AI came up with a solution for 9 queens. And then you copy and paste that code into a real application and then try to compile it. And then phase 2 is I'll explain what retrieval augmented generation is later in just the next slide. But think of retrieval augmented generation as a way of helping the AI consume more and more information about your project. And the context windows expanded. The amount of data that an LLM could take expanded from like 4,000 tokens, which is like 3,000 words, to the latest models from Google can take in 1 million tokens, so about 700,000 words. That's a lot of code. So the idea there is that all of a sudden your code base becomes a searchable database. And then the final phrase, which is where we're getting now, is what you might call thinking models. And this is when the AI stops from being just simple next word predictors to having what they call chain of thought. It can do multiple steps. And you can basically set down a plan and it will then execute the plan. And it could reason beyond simple generation. And then the final stage is where we are now. And I think we're going to stay in this world for a while, which is the agentic loop. So what we will see is the emergence of fully autonomous AI agents. And you'll see today, this morning, I discussed with an AI the spec-driven project. Then we went to the next stage and we said, let's build a phase plan. And then I said, implement. And I walked away for 2 hours and I came back and it was done. And I ran it and it just started the first time, right? That's how good these agentic systems are. You need to know how to tell them to do their job very carefully, but that means that it's something that's learnable and the next generation of models will be able to do that out of the box. So I want to talk a little bit about RAG because it's really important to understand RAG. Again, I still don't know how much people know. Do people here generally know what RAG is, or should I explain it? All right, so this is how LLMs used to work, right? You type in a query, and then the LLM just starts predicting the next word, right? Like code that does blah, 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 and it will tell you warn me, right? But basically what it's doing is you're just prompting from whatever was used to train the model in a very, very ambiguous way, right? And the big revolution that's happened is, the way I think about this is if I ask you what you had for breakfast, and your memory's not going to be that great, right? Because who knows? It's not something that you usually remember. However, if I attach a database on the side, and before I ask you what you had for breakfast, I say, okay, here's a log of all of the things that you've done this morning. Here's what your log says you had this morning for breakfast. And then I feed it to the LLM and I say, this is the information I was able to retrieve. And it gives me a list. That's going to result in a lot better code. So again, imagine that you have a code base. I take the code base. I use embedding, which I'll discuss in a moment, to create a vector database. And then when I ask you to modify code, instead of asking you to modify code from the blank page, I give you samples of the code that you might have found useful, right? So for example, what I might do is I might say, I'm going to put the entirety of Stack Overflow into my vector DB. And now when someone asks me how to, create a button in TypeScript, I'm going to give them the article from Stack Overflow that explains how to create a button in TypeScript. And so now, instead of the prompt being create a button in TypeScript, the prompt that the LLM actually looks at is create a button in TypeScript, and here's a Stack Overflow article about how to do that. Go. And so because you have the contextual information, it's going to lead to a much higher quality product. And this is what they're all based on now. So all of the agents, web search is an example of a retrieval augmented generation system now. Yep.
I don't know if it's going to be controversial or not, but half the things you'll find in Stack Overflow are wrong. So it's going to spit out things that are maybe correct, or combinations of things that are right and wrong, or just flat out wrong.
The way it works is that it would spit out everything, the right and the wrong. And then what would happen is that the LLM would get 3 articles now. It would say, this is article 1, article 2, article 3. I don't know which one of them is right, but one of them tells you the right way to create a button in TypeScript. You choose. Which is an okay solution, right?
It's worthwhile to say it's also looking at the responses to those articles, with people saying, that's wrong.
Yes.
Or, man, that solved my problem.
Yes. So if there are comments on the article, that also becomes part of the context, right? Now, the key thing to understand here is the embedding model. Essentially what this is it takes any content that you have, like a document or a picture. Embedding means converting any document you have into a vector, usually around 2,000 numbers. So and that vector represents the concept itself. So in this vector space, concepts like cat and dog are close together, whereas cat and Sydney are not close together, right? Think of that as a semantic encoding. And it uses the same type of transformer models that we talked about earlier. So the way those transformer models work is they're a stack. That's usually like a stack of 30 of them. So imagine that and the bottom stack is like super syntactic, like it's composition of words, and it gets progressively more conceptual as you go up the stack. And at each stage, you have a representation of the state of the system. So the embedding is essentially a vector representation of what the system understands, the semantic representation of what you have. So every article gets converted into a vector of 2,000 values. And so then when you ask a question like button TypeScript, it then encodes those two spaces into that 2,000 vector and finds all the articles that are close to it. Great. So now you all know what RAG is, and you know how it works when you search for something on the web. So this was another topic I thought would be a fun debate, but I have a reference here for it, and it's someone we both respect. So when we're talking about agentic in this context, what we're really talking about is an LLM that executes in a loop such that it looks at what it's doing at each stage. So it's very much like the reinforcement learning idea of an agent. There's a world, you observe the world, you pick an action, you undertake that action, you reflect on the outcome of the world. It's basically what it's doing, right? And there are 4 characteristics when we talk about agents in this environment. There's generally 4 characteristics that we're looking at. The first is reflection. So you write a piece of code, and then you say, did that code do what I wanted it to do? So for example, and something that you would look for is if you wrote code, you want to check that it compiles, right? If it doesn't compile, you go, why didn't it compile? And you fix it, right? So that's what we mean by reflection. You generate some output, you then use the output, analyze it, and see if it's right or not. The second thing that you do is tool use. So imagine that you're trying to book a flight. The LLM doesn't know how to book flights, but it knows that there's a tool called Book Flight that if given a flight and a date, will book the flight for you. So then what the agent can do is it can book the flight for you by essentially calling a function. So when we're talking about tool use here, what we really mean is giving the LLMs the ability to call arbitrary functions to get information from the outside world and to affect change in the outside world. The third one is planning. And this is very, very traditional for agents. And that is that you run these things in kind of a 2-phase approach. Before you do anything, you basically ask it to write a plan, and then you ask it to carry the plan through. And this has been proven to lead to considerably better results. Who here has used Google Deep Research? Okay. I thought I would get like 60% at least. If you have not used Google Deep Research, please go explore using Google Deep Research. It will make your life a lot happier as a researcher. Unfortunately, in the case of my wife, who's also an academic, it made her a lot sadder because it made her question what she was doing with her life as well. So be very careful, but really have a look at Google Deep Research. There's 2 things I would recommend that you don't make, well, there's a lot of things, but Workbook LM and Google Deep Research, right? Those are 2 things. Homework tree guys, please explore these tools because they will amaze you about what these things can do with AI. Right? And then the final one is multi-agent collaboration. So let's say I have an agent that specializes in writing code and another agent an agent that specializes in back-end code and another one that specializes in front-end code. They have different data sets that they were trained on or fine-tuned differently. Then I can have an orchestrator agent that says, okay, you write the back-end, you write the front-end, here are the specs for how the back-end connects to the front-end, right? So when we talk about agents, that's what we mean. So hopefully now you have an understanding of what I mean by the agentic revolution and why retrieval augmented generation was such a key thing. So the next thing is the problem with vibe coding. So everybody here knows what vibe coding is? All right. So vibe coding is this idea that imagine that you have, and there are companies that do this. There are companies like Replit and Lovable. And you basically give in a prompt and out pops an app. Right? And everybody thinks this is awesome. And now that, people are saying this is the end of programming. But now there are people whose job it is to take the people that, take the code that was generated by vibe code and rewrite it so it's something that's sensible and doesn't want you want to pull your eyes out, right? Because it's complete spaghetti code, right? And there's a reason for this, right? So if you try to write vibe code, if there's a bug, you basically don't know how to fix it because there's no but the AI wrote the code and it did nothing. Like you didn't have nothing to do with it, right? It just looked really good, looked like it did the right thing. You had one feature, the whole thing falls apart, right? So the analogy I give, and I have so this is an AI generated image that I generated for one of my images. What was the technology that generates this? Does anybody remember what it's called? Stable diffusion? Okay, great. So the way that I see it is I see vibe coding as like trying to use a chainsaw blindfolded, right? On the one hand, a chainsaw is incredibly efficient. And anyone who's trying to use an axe in this day and age doesn't stand a chance against a chainsaw. On the other hand, chainsaws cause 30,000 injuries per year in the United States. So the problem isn't the chainsaw. It's great that we have a chainsaw. The problem is people do not know how to use the chainsaw correctly, right? And so I feel like vibe coding is kind of like using a chainsaw blindfolded. And so you end up with a lot of blood everywhere, right? That's the problem. So these are some of the issues that you get with vibe coding nonsense, right? These business people nonsense, right? So when you just use pure vibe coding, you get problems like it creates a mock. So, it's good to say, write tests. And then it creates a mock, and it mocks everything, including the function that you were trying to implement, right? And so you end up with this mock that essentially is a test that always returns true because it was all mocked all the way down. And, or another example is you fix a bug, and then it's like, great, we fixed the bug. And then you come and say, okay, fix this other bug. And in the process, it undoes the first fix to the bug. These are some of the things that happen with vibe coding, right? And I've had all of these happen to me. Another one is version number chaos. Like the number of times I've had to tell AI to use Gemini 2.5 because when it was trained, Gemini 2.0 only existed. I would pull my hair out. I keep saying Gemini 2.5, which is the latest model from Google. There's no reason. And so it just is a very, very painful one. This debugging tail chasing is the most irritating one, I think, which is it tries to fix something, it does a reflection, it sees it hasn't worked, it tries exactly the same thing, it fails, it doesn't work, and it just keeps going round and round works, right? So this is why vibe coding is a bad idea. And so I was really reflecting on this because, the promise of vibe coding is so exciting, right? You type in code and then out pops an application, right? That's a beautiful idea, right? But the problem is that you have to understand that when it comes to AI, natural language is effectively the source code, right? Because the natural language is the actual specification that has the information required to create the app. And so what you do in vibe coding is you open a window and you have a conversation with an AI, and the AI generates the code. The conversation is thrown away, and only the code remains. Effectively, that's the same as having a C++ compiler, and you take a C++ code, you compile it to assembly, and then you throw away the C++ code. Like it's a really, really bad idea, right? So people seem to be okay with this now. And so I think the core problem here is that when you throw away that conversation had all the context. The context is what helped the AI make good decisions because it knew what you were trying to accomplish. If you just look at the code and try to reverse engineer the context, it's not going to be a faithful reproduction. So the core presumption that I have that I want to capture is that the context and the specifications are now the code. And you must capture the specifications and check in the specifications as documents into your code base the same way that you would check in code. And that's because the specifications are the things that actually lead to the generation of the code. It's almost like AI is a natural language to JavaScript compiler, right? That's effectively how we're using it right now. So there are lots of side benefits for that, right? Someone can understand exactly what you're doing after this. So, and it just becomes much, much cleaner. Right? So I'm going to stop now and dive into Claude Code. So let me see if I can do this. So before we dive into it, who here has used Claude Code before? Not Claude Code, specifically Claude Code, the command line tool, the terminal tool. Okay. So the way it's a beautiful tool, but the way to think about how it works is the file system is shared context between you and the AI. It's like there's a common brain. When you edit the files, you're changing the AI's brain. And when the AI edits the file, it's changing your understanding of the problem, right? But the great thing is you can teach it as you go. So now if you have a file called Claude, I'm going to say your name a lot, but so the way that these projects work is that there's a file called claude.md that has instructions that you want the AI to follow. And so when it makes a mistake, the way that you fix it is you say, please update the claude.md file. For example, if it checks in, this happened to me this morning, I swear. If your AI decides to check in a file with a key to Gemini, which if it's captured publicly could be worth thousands of dollars, you need to tell it, please don't check in API keys again, right? So then you tell the AI, edit claude.md so that you never check API keys again, right? And so there's this kind of teach it as you grow, because now it's doing RAG over the whole code base. And every time it tries to kind of check in an API key, something should come up that says, oh, that's a bad idea, right? One of the most amazing things about these Claude Code is ad hoc tool creation. And I want to give you a real example from yesterday. Does anybody know in a Mac how, if you have something in the clipboard, an image in the clipboard, and you want to convert it to a file, how do you do that? I could not be bothered researching, so I just said to Claude, not that Claude, that Claude, please write some code that will take what's in the clipboard and save it to a file. And it did it. It wrote some Python code. There's a command in Max called pbcopy that captures what's in the buffer. And now that's how I convert things in the clipboard to images that I can then do whatever I want with, right? But it's kind of crazy, right? Like I never had to use any part of the operating system. I did not give it any guidance on how to do it. Just searched the web, found the library, found out how to do this, and wrote Python code on the real time. Okay, and the final two that I think are really interesting is something called model context protocols. So model context protocol is a protocol for AIs to talk to other AIs, right? Or AIs to talk to other tools, right? So in my particular case, I have, and so it's just a way of expressing tools. We talked about booking airlines. You might have an MCP server that allows you to book airline tickets. You might have an MCP server that gives you the weather. But you might also have an MCP server that says, send this request to another LLM in similar sense, right? So I have two favorite MCP servers that all of you should get to know. The first one is Zen. And what Zen does is if you're using Claude, it can send requests to either GPT-5 or Gemini to ask them their opinion. So in other words, you say, Claude, generate this code, and then you say, okay, give it to GPT-5 and review it, right? So Zen is the first one that we're talking about. The second one is something called Playwright. So imagine that you're doing front-end development, like you're working on the front end or something. You want to press buttons on the interface, right? So what Playwright does is it opens a web browser, it takes a screenshot, it reads the text on the screenshot, and then decides, so in my case, I'm working on a to-do manager, it will then look for the submit to-do button, it will type something into the input box, and then it will generate a pseudo mouse click and drive the web browser, right? So now I can have if I'm trying to debug something, I can now just let it run open loop. So let's say it's trying to test my to-do manager. I said, you just go and keep testing it until you find something that works, right? And so it's going to update the front-end code, try to submit it to do, it'll detect an error, it'll work out what the error is, it'll fix the error, and keep going until it can do it again. And those type of refinement loops are very, very powerful because it means you do not have to intervene as part of the debugging process. So the way that Claude works as Claude Code works is that it goes in this infinite loop, right? It takes a prompt from a user, it creates a plan, it implements the code, it reads the files to see how everything is going, and it has capabilities like file system access, it can run bash. So honestly, I think Claude Code knows Git better than I do, and I asked Claude Code for help with Git. Okay, I must know what a question is. Who here has used Git? Okay, finally. Right. So the key thing here is that we have to treat context as a first-class citizen. So let me just go to the demo now. So we're just showing get started here. This is how you run Claude Code. It just runs in the shell like this. My code is, it's analyzing the code base, it's trying to do everything else. Right. So what I've done here is I started a project this morning. Go in the day. All right. So Claude wrote me a nice little script that that says demo help that gives me all of these commands, right? So initially our code base is going to look like this, right? Okay. There's nothing in here. There's just this script that has Claude in it. The code on leave, right? Making it better. Okay. So size it up a bit. It made it more than this. Okay, larger fonts. Yeah. So it talks about how we set up the code. It's got details about it, everything else, right? And I designed a protocol called Codev. And at some point, I asked it to construct specifications. So I'm going to close all of these windows. So this was the initial state, right? There's not a lot in here. So now I'm going to advance to the next state. So the first thing I'm going to do is I'm going to install Codev. So I'm going to advance now to this one.
I'm a bit confused about what you're doing here. Can you
Yeah.
I'm not sure again.
All right, so here's my. So this is the project that I'm trying to accomplish, right? I want you to create a web app that's basically a simple to-do list manager that has a conversational interface. That's the goal that I'm trying to accomplish. I give it some specifications. This is what I start with, right? And I'm going to see if I can show you this, which is the conversation I had with it. Right? Yeah. And then I say, I want to give you folks a demo. And so I introduce it to the Codev code base. And I say I want to move between snapshots. So it tells me which inverse I should do. And then what I do is it then goes on to set up all the branches. And we're making sure I'm looking for the right thing. So what I'm going to do now is advance to the point where we have installed Codev. So Codev is like a library, and you'll see that there's a new directory here called Codev. And in there are various protocols that we use. So the protocol we're going to use is something called Spider. And what I have with Spider is a sequence of steps that I am instructing the agent to do, right? So basically it says this is how you undertake a project. So the way that Codev works, I'll explain in a moment, is it goes through a sequence of steps. And this first step is the step for constructing a plan, the step for constructing a specification, right? So this is the file that tells it how to construct a specification. And there are different protocols available in here. But what we'll see is there's nothing yet in the specs stage. So then the next thing I have to do is advance to the next one. So it's just really hard with the font being this small. So I'll have to go. So the next stage we have to do is make a spec. Okay. All right. So by this stage, what's happened is I now put in this prompt, right? And it's now used that to generate a specification. So now, if I look at the specs, there's a new file here called conversation. And this discusses, what features we want. It's a web-based to-do manager. It's a traditional to-do application. But what I wanted to do is add a box to the bottom of the window that allows me to type in, delete all of my to-dos or whatever else. And then what it does is, this is its first draft, right? So I've asked it, this is my prompt. This is my prompt. Look at this prompt. Use this description of what I want in terms of a specification and generate a spec file. That spec file is now checked in, right? But the next thing that I want to do is to go to demo spec review. Okay. So now what's happened is, it's got a description here. I've reviewed it and I've left feedback. So what's happened is, I've taken that design doc that they had, right? And I've gone through the spec document and clarified the things that I want to check, right? So for example, I say that it seemed to think that I wanted just a conversational interface. But you can see as I go through here and look for colors, I emphasize we need both. This is the type of one that you want to catch in the design stage. So what it was doing was it was going to give the user my API key. And I said, please don't do that. Please keep the API key for calling Gemini on the server. And so I'm updating it. And I'm saying, okay, you have to be able to update the to-dos from the text box at the bottom and also from the UI. And then it says, I'm going to do side by side. And I say, no, I want top bottom, right? I want the list of to-dos at the top and the chat window at the bottom, right? And it's doing fancy stuff with cards. I tell it, don't worry about any of that stuff. I tell it that, I should use this particular library for the UI. Right? And then, again, AI does random acts of randomness. Is when this AI was trained, the version of Google Gen AI to use was the older version. So I have to correct it and say, no, use the new version, right? But this is all at the spec level, right? It's deciding, and then, there's also the API. So I don't want you to use API, I want you to use MCP. And then I say, you should be using this interface. So what I'm going through here is I'm going through the design that the AI generated and leaving a bunch of corrections that I wanted to undertake. Is that clear? Let's go through that again. I have a prompt. I give the prompt to the AI. I say, AI, please generate a spec for this prompt, right? Generates the prompt. I read the document that it generates, the spec that it generates. I say, here are the problems that I spotted with your spec. And then the next stage is that the AI reads my problems and updates the spec. All right. So then this is the next stage of development, right? So after this, it's gone through all of my comments and it's updated the specification to address them, right? So if I look about, we were talking about SHA-CN earlier on, that's now part of it. And then if I look for, say, the API key, let me see here. All right, so it's now added this section here that says you do not expose the Gemini API key on the client, right? And so it explains how it solves that problem, right? So it's gone through my criticisms and analyzed, right? And so the next phase after that is our plan. Right. We've got the spec now, right? What we're going to do is take that spec and convert it into a sequence of steps. That's what a plan is, right? So now I ask it to come up with a plan. And we can have a look at the plan. And it has some technical decisions in here. But if I look for phase, we'll say the first thing we have to do is set up the project. The second thing we have to do is set up the core types. And so it generates 8 different phases. And then just like before, I'll review it. And this time, you'll see that I leave some comments in here. Right, it wanted to do multi-tab synchronization, so if I have 2 tabs open with the to-do list, I said, don't worry about that, right? I said, I'm reminded about something. I said, don't worry about offline. I said, please make sure that you test every phase. And I said, don't worry about phase 8, because I wanted to switch, right? So I've gone through the same process. I've taken it, it's created a plan that's 8 steps. And then finally, it also integrates things, right? And I'm saying, updates, right? And see, this new plan has fixed all of the issues that I promised, right? So now I have a plan. And now all I do is I tell it to implement it. And that's what I was just doing. And now that it's going to implement it, I wait for it to finish implementing. It takes about 45 minutes. I try to run it. And that takes us through to like the fine-tuning section. And while I was in that fine-tuning section, I found 2 issues, right? One was that I forgot to give it the Gemini API key, and the second was that it couldn't actually, it couldn't edit dates or something like that. But when I tell it to run the application on localhost, I'm swearing at PI. And the funny thing is, according to some research, it works. Because again, I mean, I know it sounds crazy, while we're waiting for it to, there we go. So now it's running the server. Should be on, it's on the wrong version, so it's just to that version. Let's see this version on. Okay. So it should be on 3001. Is that right? I did not touch source code once. I want to repeat that. I'm not even good at TypeScript. But because we formulated and given context in such a clean way that the agent knows everything that it needs to do, we have an application here, and I can kind of like add to do is it MSW or what about Claude? That's it, right? I can do like a due date, whatever else, right? But I can also say this, like add cute emoji. I've never tried this before to my to-dos. Maybe not. Okay, there we go. Done. So now I'll put little stars next to each of them, right? Or I could say, you know, make all of, you know, make all the a due date of one which he will go through and edit them and set the to-do dates and everything else. But so I spent a lot of time on the spec. But remember how many corrections I had at the spec? Like I had like 15 different corrections. Still have some work there, we said some of them. But it's kind of incredible that we have something that's up and running. It seems to be somewhat working. I'm sure there are some bugs in there. But then we just use AI to fix those bugs. Now, not only that, but we have a very, very comprehensive suite of specifications. Right? So we have the specifications for the things that we just built. That explains how it works. We have the plan for how we built it. While we're ready, I'll ask it to create an architecture document. You use architecture document, but to create update the design. It's now going to go through and create an architecture document. Right? That's big part. So we're almost done. Don't worry. Subject to is too much longer. Once I find my. So I think we've walked through most of this, but the core philosophy is natural language becomes a durable version form of source code. We version everything, we iterate by leaving comments on things, we have agents validate each stage. So at the end of I mentioned the MCP server, at the end of the spec stage, it doesn't just stop there. It continues and says, can you get feedback from GPT-5 and Gemini? And we have essentially executable documentation. So this kind of like, let's generate a description, we do a commit, we leave a comment, and we ask it to update it. It seems to work very, very well because it creates a record. Are you giving me a signal that I'm picking too up?
Well, no, so do you want to leave some time for questions?
Yep, almost there. So I think we've covered most of this. We talked about the protocol, and so the plan is basically do specification, plan, and then you go through implement, defend, evaluate cycle, and then basically review to make sure it works. And so I think we lived through this. So I'm just going to spell over this to give you guys some time to answer questions. But let's skip this section. But a few interesting things to talk about as well, right? One thing is how I install. If you want to use Codev on a project, how do you install it? Is there a script? No, there isn't a script. There's an install.md file that is instructions for your Claude about how to install it, right? Because your local environment knows exactly what it needs. It knows where all the files are and so even to install it, you're basically invoking an AI to interpret a set of natural language instructions. So this is what we got. I won't show it, but all right. And we talked a little bit about MCP and how I use the Zen MCP server and the Playwright server to test things. They're basically protocols for AIs and tools to talk to one another. And we talked a bit about the Zen MCP server already. And one thing that still works, even from classical AI to modern AI, is ensembles are still very hard. So ensembles have always worked very well. And in this particular case, having Claude, Gemini, and GPT-5 work on the specifications together, each one of them has different strengths. Gemini tends to be very good at theory. GPT-5 tends to be very good on user interface design. And so once again, we're back to the days of bagging and bounding, rainforest and everything else. So in conclusion, it used to be that documentation was off, right? It used to be that sometimes the documentation would be up to date. But what AI has done is flip that over its head. And now the documentation is really the source of truth. And so what we should be thinking of when we're designing AI is the specifications of a source code. And the key templates like number one, stop line coding. Number two, develop your specs in a systematic way. And number three, use things like MCP, multiple servers, Playwright to help you write better code. So practical next steps, students should learn to use the technique that I've invented, of course. But academics, there's a lot of research opportunities, and I think this spec-driven development area is actually very, or the human agent AI code development is a very fertile area for research. And the final thing is, here are some links for you to look at afterwards. So with that, I'll leave 6 minutes at least for questions and answers. That is my email address. Don't hesitate to drop me a message anytime. Happy to answer.